It seems you already have presented half of my presentation, so perhaps I will do it just in 15 minutes. It's a great honor to be here on this stage, a virtual one though, but still. And then I had been invited to make a presentation here. I started to think about what I can tell you. And I thought, well, if the topic is demystifying the data science, why not to take the most common, the most simple thing, such as grocery store, and show you and tell you how the data science and machine learning can be applied for even such a basic thing, how we do that, for not in technical details, because I'll just give you a brief overview of some of the projects and why we do that. So the couple words about an X5 retail group. As Dilara has already told, it's the largest retail chain in Russia. What does it mean largest? There are more than 17,000 stores around the country, and more than 300,000 people work at X5. And the revenue for the last year was around 30 billion US dollars. So right now we have more than 500 people working in big data. That includes machine learning engineers, data scientists, data analysts, software engineers, quality assurance, set project managers, product managers, and many more. And well, Dilara has also mentioned that I'm senior director at X5, and I was previously working at Yandex, and I also teach data science in National Research Institute Higher School of Economy. It's quite a rare occasion that time, but in recent years I was teaching more. And yes, I'm a Kaggle competition grandmaster. And the reason I'm telling you is not only to boast about myself, but also to show you that I know not only the theory, but I also know some practical stuff. And if you are interested if you have any questions, feel free to ask them. So go to the business. What I'll do, I'll show you a diagram, maybe a number of products, whatever you call that. And I'll discuss not all of them because we're limited in time, but some of them. And I'll start from the basic thing, which is called demand forecasting. Imagine this story. You want to buy chicken. And why you want to buy chicken? Because you had a hard day at your job, you are tired, you are hungry, you came to your home, and there is a proximity store near it. That's why it's called proximity. And you came to the shop because you would love to make something delicious and at the same time healthy. So you decided that chicken breast is an ideal solution for that. Then right now you're in the shop, you are reaching the freezer or shelf or fridge, whatever, and you're trying to grab your favorite chicken brand, and there is no chicken. And that's the biggest problem for retail because, well, you are dissatisfied as a customer, and if there is other chicken, perhaps you will take it. Or in the worst case, you will leave the store and will go to the competitor. So we are losing you as a customer and competitor is gaining you. That's a complete disaster for X5. The one way to solve this problem is pretty obvious. Well, if we know that on average we will sell 100 tons of chicken, why not to buy 150? So we will sell 100 and we will have 50 more. Not a big deal. Of course, it's a loss, but we have sold all the chicken that has been demanded. Well, apparently, then the next question arises. Why not to buy 120 tons of chicken? Because to lose 20 tons is better than to lose 50. And thus we came to the solution. We need to develop an algorithm which will forecast the demand. The problem here is that we have 17,000 grocery stores around the country and we have more than 8,000 unique stock keeping units in each store. So that means that we have to make a prediction for more than 120 million unique items each day. That's quite tricky to do, but still it's manageable. The only problem here that further in the future, harder the prediction is. So what we do right now, we are predicting the demand for the next 30 days, for months. We are pretty good in that. And basically that's what we are doing. One of the product in X5, we are predicting the demand. And that encapsulates such things as trading, boosting decision trees, time series forecasting, some staking, and more than 600 features. But I will not dive in technical details because it's not the reason of this presentation. If you are interested in, and if you're a Russian speaker, or if you speak Russian, or at least you understand Russian, there is a presentation on YouTube given by myself. It's close to 90 minutes long. And in this presentation, I'm describing the demand forecasting in details. But suppose we've made a good algorithm. We can forecast the demand. Then another question arises. Imagine again you're a client, you're a customer, and you want to buy something. Well, imagine imagine maybe not you, maybe something, not another customer wants to buy beer. And after the customer took a beer and put it into the basket, what then? Maybe the customer will take another bottle. Maybe the customer will go to the cashier. Or maybe the customer will take some snacks, which makes sense. We know, based on our daily experience, that snacks are pretty good with the beer and they just link together. So, having this information, what shall we do? Perhaps we would like to put the snacks in far corner, further away from the beer, so the customer will have to walk through the whole shop and maybe the customer will buy something else. If our metric is just to increase the average time spending in a shop, maybe it's a good solution. Maybe if our metric is to decrease the number of minutes the customer is spending in the shop and just make the purchase as fast, as simple as possible, it makes sense to put the snack stand just close to the beer. And this example of beer and snacks is pretty obvious, but there are, as I already mentioned, around 8,000 unique items in a store. So how can we find out which items are linked to which items? What we have receipts. We have maybe 15 or 20 million receipts per day. And these receipts, we can calculate the conditional probability of existing one item given another. So we could just build and find out the probability matrix and understand if the probability of two items are independent or they're linked together and they're conditioned. And that gives us a huge leverage, a lot of information how to put our stands within the shop. But then there is another question. The number of stands we can put in the shop is quite high, but the area of the shop is quite limited. And so what we have to do, we have to understand what shall be the distance between the stands, between the shelves. Because if there is no distance, obviously there is no way the customer can go through the stands and buy the items which is on the stand. But if the distance is too big, that means we are not using the limited area of the shop in an efficient way. And that means that we have to calculate the most efficient and most optimal distance between the shelves. Sounds like a pretty easy thing, but that's quite tricky because that depends on what is on the shelf and the type of the shop. Basically, we're using here type of Bayesian bendings, trying to understand which distance is the better one. We'll switch to recommender system, and we'll talk about the computer vision because it is quite linked to the previous ones. Imagine again you're in the first story and you want to buy chicken, or someone wants to buy chicken. And again, the same problem. There is no chicken in the fridge, or on the shelf, or on the freezer. But the reason of this is completely different from the first one. It's not because there is no chicken in a warehouse or storage room, but because the chicken hasn't been yet replenished by staff. Maybe it's a rush hour and there were many people before you and they took all the chicken and the staff just didn't have enough time to replenish it. The same problem, but even worse consequences, because the first part of consequences is that you as a customer can switch to another grocery store, or you can move to another shop, or at least you'll be dissatisfied. But then we also have a problem with our demand forecast algorithm, because then we will tell this team that, guys, you've predicted that there will be demand for 100 tons of chicken, but the demand was only for 90,000. That means you have to retrain your algorithm. You have to make it better because it gave us wrong outputs. But actually, the algorithm made right outputs. The problem was not in the demand. The problem was in the replenishment. You see, if you have a problem with replenishment, then you'll have a link of problems with demand forecast and further away. And one of the things how we can solve this problem is to deploy the computer vision and algorithm and camera, which will detect that the items of the interest are close to be over, the shelf is close to be empty, and so the responsible person, the member of the staff, will receive an alarm and will replenish the item before it is out of stock, it is out of the shelf, because it's still in stock. And it's already deployed. If you're interested in the details, take a look on the YouTube. The person of interest is Arthur Cousin, who has made 3 or 4 detailed technical talks about how this system has been developed, how this system has been deployed. And we saw a great improvement, especially in categories such as fruits and vegetables, because those are categories which have to be replenished pretty often. Some categories, they have no need to be replenished as often as others. But there is other thing we can do with computer vision. I guess you have many loyalty cards from many different organizations. Perhaps you have a loyalty card from retail chain, perhaps you have a loyalty card from pharmacy, or perhaps you have a loyalty card from any other business. And what business needs a loyalty card? Because a loyalty card in offline business is one of the few means which can help to track that this purchase belongs to the same customer as another purchase. So actually, it's a means of tracking your experience with a business. Another reason is if you have a loyalty card, that means you have some discount, and probably you will have a higher probability to come back than you will go to another business of the same type. But there is a problem with the loyalty cards. The first problem is that the loyalty card can be lost, can be destroyed, can be given to another person, can be forgotten. It's not a stable idea, especially if we're talking about the retail chain. For example, we have a number of clients who are visiting our stores, our shops for more than 10 or even 15 years. And believe me or not, the plastic card will not survive such a long time. So that means you have to make a new one, and some information is lost, and you have to try to merge 2 loyalty cards into the one profile. And the second problem, that the loyalty card is usually made of plastic. Plastic is not the best material, especially for our environment. And of course, it costs some money to print these cards, and it's not eco-friendly. So if we can avoid using the loyalty cards, we will decrease the cost for the loyalty card, and we will decrease the load for environment. And what is a good idea? What is a stable idea which every customer, every client, every person has? That's a face. Face is quite a stable idea. It's I still think it's possible to lose your face, and there is even the saying, but it's quite hard to do. And so the recent technologies, they give us an opportunity to distinguish one person from another, given only the picture of the face with a pretty high precision recall. So no problem to do that, except for one. Except that the face recognition is kind of gray zone, because even if you are not storing the faces of your customers, even if you are storing the hash of the face and some vectors in some space, is it personal information or not? In Russia, it's not yet, but if it will be, well, we can have some problem with that. Well, it can be solved with receiving a consent. So if you're receiving a loyalty card and you're giving a consent to store your personal information and the face hash as well, and then the problem is solved, but it takes time. So what we did, we decided to deploy this face recognition algorithm for our employees because they can give us consent. And we are using that as a control system instead of ID card. The only thing you need is just your face, and then that's it. You are inside. And that's great solution, which reduce cost for these ID cards, and which also gives us opportunity to decrease a fraud. If you're interested in what kind of fraud, you could ask me after the presentation. I will tell you into details. Voice assistant will skip, and dashboards. Dashboards is pretty easy things if we are talking about technology, but it is one of the most crucial if you are top manager or decision maker. Because what dashboard allows you to understand what the current situation is. Imagine the situation: you are driving a car, and what you see through the windshield is not what it's right now in front of your car, but what was in front of your car 20 meters before, 20 meters ago. Well, if you're on a straight highway and there are no cars in front of you, you can ride for a while, but maybe not for long. And to understand what the situation is crucial to make a right decision, because you can't control what you can't measure. And that's that the dashboard allows you. It means that in our case, you as a top manager can see the situation on the level of the shop, or the cluster of the shop, or the region, the macro region, or the whole country, and you could see the history, you can see the trend, you can see everything. So you can just see the funnel from the top to bottom, many metrics, and understand what is happening. The technology is pretty easy. It's basically a number of tables in any system you prefer, and the Tableau, click view, whatever you like. The only problem here is that if you have a lot of information, you have to write down an efficient near linear complexity time code. We'll skip a loyalty program, HR analytics, user profile, strategic planning, and GIS, Geographic Informational System. I came to X5 2.5 years ago. I was astonished to find out the number of shops X5 opens every day. 8 shops per day. As far as I know, this conference is already running for 4 hours. That means that during this conference, X5 has opened 4 grocery stores. For me, it's a big deal to open even one, but to open 8 stores per day and doing so for 3 years in a row is something mind-blowing. And it's real. But here's the problem. There are many places where you can open the store, and not every place is equal to any other place. We need to find one, the best one. And that's why we need to predict how successful will be the grocery store, will be the shop, if we open this shop in this location. And we started to predict the revenue. But the revenue, especially in Russia, is quite a noisy metric because we have quite a great and big inflation rates, and we have some problems with the currency exchange rate. The recent one was in March. The one before it was in 2014, because it was just 6 years ago. The exchange rate rubles per dollars was 30 to 1. Now it's 80 to 1. Now you can see that it's quite noisy. And the better metric to predict and more stable one is the traffic. The traffic is the number of clients or number of purchases we will have per day after 1 year, 6 months. And we built this model, and we found out some interesting stuff. The good models, have a number of properties, and one of the properties is the property of residuals. The residuals of good model has mean in 0, and normally distributed, anormally distributed, and independent. And then when we checked the residuals of our model, it was the case. But then we checked the residuals of previous model, and previous model was just a decision of experts. So it's also the model, but model based on human behavior. We found out that it's biased, and it's biased to more optimistic predictions, because people who are responsible for opening new shops, they have a KPI, and their KPI is to open number of shops. And of course, then they have an opportunity to open the shop. They're more inclined to open it than not, and they're overestimating the future success. Model has no emotions, and that's why model has no bias in that case. And the interesting stuff that we tried to include the photo of satellite images, and it gave us a small boost in accuracy, because on satellite images shows you are there any roads, parks, how buildings are situated, what kind of buildings. And we're also using the information from Google and Yandex Maps, like distance to hospitals, to the subway, to the cinema, etc., etc., etc. Within our own data, there's a proximity to our own shops, the proximity for competitor shops, etc., etc., etc. And this algorithm has been deployed. It was deployed 2 years ago and still working quite good. And actually, all these products, all these algorithms I told you about, they are deployed, and they are real deal. So they are working. Maybe I will skip the dynamic pricing, and I'll skip the chatbots, because I would love to give you just a quick overview. And I'll tell you everything. It will take too much time. But if we will have time in the question and answers section, and if you're interested, I can give you information, no problem with that. What I would like to show you and to tell you is about A/B testing, because I already mentioned that if you can't measure it, you can't control it. And I've mentioned that we have succeeded in this algorithm, in these products. How do we know? Did we have a success or did we not? And for that reason, we have introduced and we have built an A/B testing platform in X5, which helps us to understand in a mathematical way with statistical significance, was there any difference, and in what way, with our product, with our algorithm, or we had no success. And right now, X5 is a close club of maybe 15 or 20 companies which have their own A/B testing platforms. And that's my pleasure to be a part of this platform and to be one of the person who tried to build and was successful in that. But the main idea here is quite simple. If you can't measure, you can't control. And that means that you have to measure the output, the effect of your algorithm as well. And last thing I would like to tell you, it's like a call to action. If you like, or if you're interested in the topics I told you about, and you would like to know more, maybe more about technical details, or maybe about some other stuff, or you just would like to find a community and you don't know where to go, there is a community called Open Data Science. It's one of the largest data science community in the world. There are more than 50,000 people there. You can go to ods.ai, and you could request an invite for a community, and it's mostly the Slack channel, which has many sub channels, and the sub channels you can find almost everything. I by myself quite often use the channel jobs, and that's the reason how I hired maybe more than 100 people or even more. So if you're looking for a job or looking for an employer, or you want to increase your technical skills, go there. I suggest you to do it right now, and you will not forget that. And you would like to find out myself. I thought there will be a link of myself, but there is no link, so no sense to show this slide. You can find me pretty easy on LinkedIn, Valeriy Babushkin. It's like written, well, it's quite a long way for the previous slide, but I'll try. You can find me like Valeriy Babushkin. On the Kaggle, there is a link to my LinkedIn, or you can find me in LinkedIn or in Facebook. It's quite easy to do. And I'll be glad to answer any question right now or just after the presentation. I know that sometimes the questions arise after the presentation, maybe not the same day. Thank you very much, and it was again a great pleasure to be here.
Thank you so much, Valeriy, for this amazing lecture. And we also have a comment about you, that you're a star of our ODS community. I can see that now. That's definitely true.
Thanks.
I have a question in the comment section. So firstly, you said that you could explain about the frauds after the lecture. If we ask you a question, I'm asking a question about the fraud.
Okay. What I mean by fraud, imagine a situation. We have 17,000 shops, and we have perhaps 20 people in each shop, and you have a director. And sorry, there is a mic here, went off. And sometimes the director has a temptation to hire 90 people, then to hire his relative, and to receive a salary of his relative, but the relative will do no work in the shop. So that's a type of fraud. And you have 20 people working on the paper and 19 people in reality.
Is that a real case that happens?
That's quite a real case. It's one type of the fraud. That's to be honest, has been written by the Russian writer Nikolai Gogol almost 200 years ago in his novel Dead Souls. So, right, like there are people on the paper, but no people in real, but still they somehow receiving the salary. So it's close. Not a new scheme. But still, if you have a computer vision and you have a good anti-spoofing system, it's much harder to make this fraud.
Got it. Thank you so much for explaining. That's interesting scheme. I knew that. Of course, I read that work by Nikolai Gogol about Dead Souls, but I didn't know that it's still happening. Thank you.
That's why he's a classic author. That means that his work is still actual.
Yep. Another question from the comment section. Not actually a question, but more of a comment from Jane, that it's so much intrusion into people's privacy with the face recognition technology, and the benefits of for business and ecology are understandable, but Jane thinks that we have a right to privacy. And what do you think? Is it an issue in modern life?
Well, no doubt we have a right for a private life. That's why it hasn't been deployed. One of the reasons. But what I think that our concept of privacy and private life has been developed, has emerged in 17th century, 18th century, maybe 19th century. And that's a good question, how we can maintain privacy from the one side. And if we are not talking even about retail network, because in that case, it's pretty easy. If you have written no consent, store no data, you're free. But we're talking about concerns of safety and security from one hand and the privacy from another. That's a philosophical question, or it's a question for discussion for many hours.
Yeah, I agree. Thank you so much, Valery. So far, these were all the questions we had in the comment section. But guys, you of course will be able to communicate with Valery later on our career panel, hosted by Polina Polonina.